All right, well, here's section 8.2, part 2. And in this one, we're only going to try to cover one main of the objective of those three that we listed the other day, and that's distinguish between a covalent bond and a coordinate covalent bond. So we're going to talk a lot about coordinate covalent bond in this section, and I want to make sure that you understand that. So we're going to spend some time on this particular issue. All right, so an example of a coordinate covalent bond happens in carbon monoxide, CO. Now, you guys all have probably had those kind of friends who, they say, "Hey, let's go to Subway or something," and then you get down to Subway, and then they say, "Hey, you know what? I didn't bring any money. Can I borrow some money from you?" You guys could probably either you've had a friend like that, or maybe you were like that, or something. But you guys can all relate to that. Well, that's kind of the idea of a coordinate covalent bond. Is one of these guys, he didn't bring enough electrons with him when he was coming. So, we have to take that into account. So let's go through kind of a few ideas, and then I want to draw the example here. But let's just talk about some of the things. First of all, what happens in this is oxygen has extra electrons. Oxygen ends up sharing or using both pairs, or donating both electrons to a pair, a bonding pair. We'll talk about that in a little bit. A coordinate covalent bond is where one atom contributes both bonding electrons. That's what they're talking about. And we usually use an arrow to indicate that when we want to show that it's a coordinate covalent bond. Even though the bond isn't any different, you couldn't, measure it with some kind of device and say, "Oh, that's a coordinate covalent bond and that's a regular bond." There's nothing like that. But we usually use an arrow just to indicate that. Okay, so let's talk about carbon monoxide. Let's draw this so you understand what this is talking about. First of all, we've got carbon. It has 4 valence electrons. Oxygen is running around with 6 valence electrons. So we're going to try to get these guys happy. And remember, 8 is the magic number. So here's what we do. We're going to share. All right, so that's good. Share there. We can share there. We've done this now, so we understand that. But look at, okay, if we start counting now, there's 2, 4, 6, 8 for oxygen, but only 2, 4, 6, or 5, 6 for carbon. So carbon is not happy at this point in time. And we know that this actual molecule exists. Carbon monoxide exists like this. And here's what happens. Oxygen says, "Hey, you know what? I'll tell you what. I will be your friend today, and I will donate both of these electrons. I'm going to put them both in. Because when we share them, we both get to count them. So I still get to count it, but you also get to count it." So when we're done, let's redraw this now. So here's what it looks like. So notice that I have these 2 electrons that I didn't need because oxygen donated the other ones. So those are still here. Those unshared electrons are still there. We've got this, and I'm going to draw an arrow to indicate that oxygen donated both. We've got 2 normal bonds, and then we've got our oxygen. Oxygen has an unshared pair. So here is how it looks with carbon monoxide. So you can see, and then this is what I want to make sure that you understand, is that this electron, this bond right here, was donated by oxygen. Both electrons were donated in there when it formed that particular bond. That's a coordinate covalent bond, and that's how that works. So both electrons in the pair came from one atom. That's a coordinate covalent bond. That happens quite a bit. It's actually pretty common, and we want to indicate that with an arrow. Once formed, you cannot tell the difference between a regular covalent bond and a coordinate covalent bond. There is no difference between those two things. All right. Now that brings us into the next thing, where we talk about a polyatomic ion. Polyatomic ion is a group of atoms that act like an ion. So it's a group of atoms They have a charge, a positive or negative charge. Most of them are negative, a few positive, but they act as one thing. A good example is NH4 plus. So let's take a look at NH4 and let's draw this, and let's take a look at this thing we've got here. We know we've got nitrogen, which has 5. It's in group 5A. It has 5 electrons. And we've got 4 hydrogens, but we have also got this plus sign. What that plus sign means is one of those hydrogens is missing an electron. So let's put him in right away. Here's my hydrogen. He's missing an electron. He doesn't have it. And then all the other ones have 1 electron, and 1 electron. So that's what happens. So when I have a positive charge, I've got to take an electron away. If I had negative charges, I would get to add in electrons and do that. So here's our normal stuff. All right, so we've got that normal bond. We did that the other day. Now we've got hydrogen over here. He's not happy because he doesn't have any electrons. So nitrogen says, okay, I'm going to share. I'll give you both of those, and he's going to donate them to that. So here's how I'm going to finish this up. I'm going to draw this like this. I'm going to draw my arrow here, and I'm going to indicate my hydrogens. All of these are going to be single bonds, but I need to indicate that this still has a charge. And usually they're going to put like a big box, big brackets around it, and then a plus to indicate that there's a charge on this whole thing. So it's going to look like that. Most of the polyatomic ions that we have, the cations and the anions, contain both covalent and coordinate covalent bonds. So we talked about these polyatomic ions. They act like an ion. Inside there, they're covalently bonded. Usually there's going to be a coordinate covalent bond in there. It just happens that way. Most of them happen that way. So we'll do a few more. All right, so let's take a look at the example problem. And they've got H3O plus. Forms by the addition of hydrogen ion to a water molecule. Pretty common stuff. In fact, that's acid. When we have H3O plus, we have an acid. So anything that contains an acid is going to contain this. So if we look at this, we've got this hydrogen atom, or hydrogen ion. It is just a hydrogen. So basically it's just a proton. That's all it is, running around. Meets up with this water molecule. Well, because this is just a proton, it is attracted to these negatively charged electrons. So it wants to form a bond. So that's exactly what happens. But excuse me. But the way it works is these electrons from the oxygen are shared between both things. So you can write it like this, where you just have electron dots. I prefer this method where I'm using the bars like that. Okay, I want you to stop this video and work out problems 9 through 12. And when you're done with those, and take a look, and I will work through those answers for you. Okay, so the first one says hydroxide ion, which is OH minus. So I've got my oxygen. It's got 6 electrons. Okay, 6. I've got my hydrogen. Now this is not an H+, so this is a hydrogen, and it has its electron. And there's a minus sign, so I have just an extra bonus electron floating around. So let's bond these two together. That makes hydrogen happy. Oxygen's getting there. It needs 1 more electron. Well, guess what? There is an extra electron, so let's just give it to oxygen, and we're good. And so I get OH minus. Whoops. I should actually draw my bond in there. Let's erase that here. So I get oxygen bonded to hydrogen. I've got unshared pairs of electrons there, and I would put the whole thing in brackets and give it a negative sign. Okay, let's do number 10, which is Bf4 minus. So boron, it has 1, 2, 3. we've got 4 fluorines. So let's go 1. They each have 7. And I always try to leave the single one close to the one that it's going to bond with. And we'll just go all the way around there. Each one of these gets 7. And we look like this. And I've got an extra electron. And it looks like if I gave it right here, it would work out really, really well. So let's put it there. And now I'm just going to make this, this, and this. And once again, I got to put this whole thing in brackets to let you know that it has a negative charge. Now so far we haven't had any coordinate covalent bonds, but we should have them in the next one. Alright, so let's do the first one, SO4 2 minus. Now 2 minus is going to tell me I've got 2 extra electrons. Once again, whenever you're trying to figure these out, things tend to be very symmetrical, pattern-wise, tend to be like something in the middle, things around it. That's pretty common. So you've got S with 4 oxygens, so let's put the S in the middle. It's got its 6 electrons. And it is surrounded by oxygen, 4 of them. So let's put these here. 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. Now you got to do a little thinking about this. But remember, I've got these 2 extra electrons. I've got those 2 guys somewhere that I can put in there. Well, if I put one of them here, then I could just make that bond and that would work out really well. So, that sounds like a good thing. Let's do that. I can do that over here too. I can do that. But now I've got no more extras. But so oxygen, this oxygen has 6, this one has 6, he's minus 2. The sulfur, he's happy right now. He could live with this. But he's got a couple of oxygens who really want to be bonded to him, so he says, all right, fine, I will donate both electrons. It's going to look like this. Okay. Now that's kind of messy, so when you're all done, I really want you to get used to rewriting. So we've got this 1, 2, 3, 4, 5, 6, my valence ones. We've got another coordinate covalent one here. And I've got this, which is just a regular single bond. I've got this, which is just a regular single bond. Now, of course, you know, you could not look at this atom and see that those are different. I'm telling you, I've told you that before, but we draw them this way anyway. All right, let's do CO3 2 minus. Same kind of thing that we did on the last one. Got carbon, it has 4. Got some oxygens. Another oxygen. And another oxygen. And we've got 2 extra electrons. So let's put these in here. That makes that easy. Put this one in here. That makes that pretty good. And now, what do we got? We've got oxygen over here. He's going to bond with this one and with that one. Because he's got to make 8. So that's the only way to get it. Okay, so now if we count carbon, he's got 2, 4, 6, 8. Okay, this oxygen 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. So let's redo this. Always kind of rewrite this when you're done. And we're going to make a C with a double bond O. We've got 4 unshared electrons there. We've got these guys here, these guys here, and we should put a charge around all of that.